Okay, our Rube Goldberg project starts with someone calling this phone, which causes it to ring and fall onto this ramp, which is electromagnetic to gravitational potential. Then, the phone starts falling down this ramp, which is gravitational potential to kinetic. Then, the phone falls into this cup, which is kinetic to gravitational potential. Once it falls into this cup, it causes this side of the teeter-totter to lift up, which is kinetic to kinetic. After it lifts up, it causes the ball to fall onto this ramp, which is kinetic to gravitational potential. Then the ball starts rolling down this ramp, and then it hits this car and causes it to roll under there, which is kinetic to kinetic. After it rolls here, the candle goes under the string and burns it, and it breaks, which is kinetic to thermal.
The string will snap because of the thermal energy from the candle, which will cause this string to fall down, and that energy conversion will be thermal to kinetic. And then it'd be kinetic to GPE, since the golf ball and the Alka-Seltzer are on the verge of falling into the water. And then it will be GPE to kinetic once the Alka-Seltzer and the golf ball fall into the water. And then because the Alka-Seltzer and water will mix, it'll cause a chemical reaction, which would be kinetic to chemical. And then on this side of the string, it'll be kinetic to kinetic, since that snaps and this string will go up. And then once that string goes up, it'll cause a chemical reaction because there's baking soda in that balloon, which will be dumped into the vinegar, and it'll cause a chemical reaction. And from the chemical reaction, the balloon is going to expand, which will be chemical to elastic potential. And since the elastic potential energy will expand the balloon, it'll cause this Lego to tip over, which will be elastic potential to kinetic. And then it'll be kinetic to GPE once the ball, this light up ball, will be on the top. And it'll be GPE to kinetic once it falls down the ramp. And then it'll be kinetic to electric, since it's a light up ball and it's electrical. And then down this ramp, it'll be electric to kinetic.
Down the ramp, and once it rolls down the ramp and hits the keyboard, it transfers from kinetic to electrical energy because it makes a sound on the keyboard. And then once it gets to the end of the keyboard, it transfers from kinetic to GPE once it falls down the keyboard. And then once it hits the book, it transfers from kinetic to GPE. And then the GPE transfers to kinetic when it hits the second book. And then the second book's GPE transfers to kinetic when it hits the third book, and then the third book's GPE transfers to kinetic when it falls down.
When this book falls, that'll be kinetic, and it will land on this button, which will make that noise, which is sound. And when it also falls, it will be pulling up this string and lifting up this cup, which will be kinetic to kinetic. And when the cup is lifted up, it will release this balloon, which will fall, which is GPE to kinetic. And then the balloon will fall into this pit onto a candle, which is kinetic to thermal. And then the air inside of the balloon will expand, which is thermal to elastic potential. And then the balloon will pop, which is elastic potential to sound. And then when the cup is lifted up, the ball inside the cup will roll out, which is kinetic to GPE. And then it will fall, which is GPE to kinetic, which will then turn on our push light.
49.
Oh my gosh!
Oh shoot!
Happy New Year!
Chemical reaction.
Someone hurry!
Oh shoot! Oh wow! Are you kidding?